Okay, this lesson we're going to remind ourselves how to add, subtract, multiply, and divide radicals. Radicals are numbers that are square roots, like the square root of 5. Now we have the square root of 4 right under it, which would be 2. We have the square root of 5, we have the square root of 6, the square root of 7, and the square root of 8. And then the square root of 9 is 3. So these numbers are somewhere between 2 and 3, and they're decimal numbers, but they're decimal numbers that don't repeat, and they don't turn into a fraction. So if we were to put one of those in, let me just get a quick little calculator here. If I were to put in the square root of one of those, so I'm going to turn my calculator sideways so it'll have a square root. Okay, so there's the square root. So like 5. So like I said, there's the square root of... Let's take 4 for the square root of 4. Okay, this one's the square root first. The square root of 4. See how that's just the number 2 right there? Okay, so the square root of 5 is just a little bit more than that. But it has, see how the decimal, so this calculator really throws a lot of decimals on there. It's never going to repeat, and it never stops, and it never turns into a fraction. Okay, so those are radicals. So they have just a little bit different rules than regular kind of numbers. So here's how they are when we add. They have to be exactly the same. This problem is kind of like negative 5x minus 5x. See, I put an x where the square root of 7 is. So negative 5 of these minus 5 of these would be negative 10 of those things. Okay, it works the same way here. We've got negative 5 square roots of 7 and negative 5 square roots of 7 for a grand total of negative 10 of those square roots of 7. And that's as far as that one goes. So they have to be like terms in order to add. So let's take a look at number 2. These are the only two that can go together. So this one is still there. And now here's negative 1 of them, and there's negative 2 of them. That's kind of like negative x minus 2x. See, I'm putting the x where the square root of 8 is. Okay, well, that would be negative 3x. So this is negative 3 of these square root of 8s. Now, one of the things that we got to do is we have to try to simplify some of these things. So the square root of 8 is actually not done. Now, these two don't go together any further unless we can make that some kind of a square root of 2. Let's take a look at what square root of 8 means. So here are some perfect squares going along the side. So I'm looking for things like 4, 9, 16, 25, 36, 49, 64, 81, 100, because these are all square rootables. These are called perfect squares. Because the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, that one is 5, 6, 7, 8, 9, and 10. Okay, so we're always looking for these kind of values because they break out of the square root. Well, look at the 8. That 8 could be rewritten as 2 times 4. And if I do that, the 4 is a perfect square. So I'm going to rewrite the 8 as 2 times 4. And now what that means is the square root of 2, but see this part, the square root of 4, the square root of 4 actually comes out as an outside 2, as a real 2. So the square root of 8 is the same thing as 2 square roots of 2. Okay, that's what I want to do with that square root of 8 right there. That square root of 8 is going to get replaced with the 2 square roots of 2. And then that 3 is still on there, and there was nothing in between there, so it was a multiply. So 3 square roots of 8 is the same thing as 6 square roots of 2. And you see how doing some manipulation on that 8 got the 2's alike again? So now we have negative 2 of them and negative 6 of them for a grand total of negative 8 of those things. So when they don't go together like they didn't up here, if we couldn't break the 8 down any further, that would have been the answer. But since we could break the 8 down, it just so happened that it turned into like terms. They both ended up being a square root of 2, so we could answer them. We could put them together. All right, let's take a look at this. Square root of 10 does. Square root of 10 doesn't have anything to break out of there because all a 10 could be is 2 times 5. And neither one of those are a perfect square. So square root of 10 is as low as it's going to get. But 40 is going to be something else. The square root of 40, that could be 4 times 10. And I chose that because the square root of 4 is really a 2. So this minus square root of 40 is really minus 2 square roots of 10. And now I want to take a look at the 250. I think the 250 will have something in it also. How about 25 times 10? See, that's still 250, but the nice thing about that one is 25. The square root of 25 is really a 5. So that is now a 5 square root of 10. So that's what this 250 is. It's negative 5 times 5 square roots of 10. Okay, with all that, let's write down what we have now. Negative 5, so the real numbers out here make negative 25. So that's negative 25 square roots of 10. We already fixed that one to negative 2 square roots of 10. That one was 4 square roots of 10, and that one is 3 square roots of 10. See, it was hidden, but they were all square roots of 10, so they're all the same, so we can add them up. It's kind of like negative 25x minus 2x plus 4x plus 3x. See, they're all the same. If we did it with x's, negative 27 plus, so it'd be negative 20. Well, that's what it's going to be for the square roots of 10s also. It's negative 20 of those square roots of 10s. Okay, so we got to look at these square root things and see if anything will break out of them. Okay, 5, that's not going to break out any further. No. 6, the square root of 6 could be 2 times 3, but none of those are perfect squares, so that's as far as it goes. So these aren't going to, there's nothing hidden here. So there's some square root of 5s, there's some square root of 5s, and there's some square root of 5s. We just add them all up. So there's positive 3 minus 1 minus 5. So negative 1 plus 3 is 2 minus 5, so there's negative, how much is that? Negative 3 square roots of the 5s, and then there's a 4 square roots of the 6. The square root of 5 and square root of 6 don't go together any further. That is as simple as it gets. It doesn't go any further because that's kind of like negative 3x plus 4y. See, they don't go together any further than that. The 5 and the 6 have to be the same in order to add it up. Okay, let's look at this 32. I don't think the 10 will go anywhere, but the 32 looks like it has a hidden 4 in it. So I'm going to break that 32 down a little bit. That square root of 32, I'll do it over here. The square root of 32 could be 8 times 4, or it could be actually 16 times 2. You want to go as big as you can on the perfect squares. Okay, so now the 16 can break out of there as a 4. Okay, so we have a 4 in the front times, and now the 32 became this, another 4 square roots of 2. So that piece became 4 times 4 is 16 square roots of 2. Okay, that didn't help. That's not going to go with these 10s. I have a bunch of square root of 10s that can go together, and then that one's going to be left over. So negative 4 of them, and negative 4 of them is negative 8 plus 3. So the 10s are negative 5, and then that other little piece was a 16 square root of 2. And now the 10 and the 2 won't go any further. Okay, that's how you add and subtract radicals. You have to make them the same. Okay, multiplying radicals, you just multiply, so radicals do multiply together. That's just the same thing as the square root of 3 times 3. So you can put it all inside of one bracket. So that becomes the square root of 9, which is 3. Number 7, we got 6 times 3. So that's the same thing as the square root of 6 times 3, which is 18. But now the 18 has a perfect square in it because 18 could be written as 9 times 2. And now that 9 can break out, the square root of 9 is 3. So we have a 3 on the outside and a square root of 2 left on the inside. Okay, number 8, 10 times 5. That's going to give us, square root of 10 times 5 is the square root of 50. but 50 has a 25 in it, so I could rewrite that as the square root of 25 times 2. Square root of 25 is 5. That's how come we changed it, because we know the square root of 25 is something. So now we have a 5 on the outside and a square root of 2 on the inside. Okay, so multiplying is pretty straightforward. You multiply it, then you clean it up. Okay, so doing the distributive property here is the same thing. All that means now is negative 2, and then inside the square root is a 6 times 3. Then we'll do it here again. The outside is a 3, the real part is a 3, and that's getting multiplied by a square root of 3. Okay, 8 times 3 is 18, 6 times 3 is 18, so we have the square root of negative 2 square roots of 18 plus 3 square roots of 3, but the 18 is not done. 18 is 9 times 2. And now the 3 that 9 is really a 3. So when they're on the outside, that's a multiplier. That's 3 times negative 2. So that's negative 6 on the outside with a 2 on the inside. And they're not going to go together any further. So I kept going to see if they could go together, but they never ended up being the same. So that's it. Okay. A real 2 and a square root of 5. That's just 2 square root of 5. You usually put the real number first. Okay, then we have 5 on the outside and then a square root of 5 square root of 5. So 5 times 5 on the inside is 25. Okay, that's a perfect square. The square root of 25 comes out of there as a real 5 with no square roots left. So here we have 2 square roots of 5. Plus 5 times 5 is 25. Those are not the same. That's it. Okay, what if we have a square root of 6 we want to multiply in there? It's all the same still, so it's a real 4 and times the square root of 6. And now a square root times a square root is a square root of 2 times 6 is 12. Okay, 6 can break down to a 2 and a 3. But neither one of those are perfect, so we don't need to go any further than that. But 12 is the same thing as 4 times 3. And I'll take that one because the square root of 4 is 2. So we have the 4 square root of 6, and over here we have a 2 on the outside with a square root of 3. And those are not the same, so that's done. Okay, what if we have two parts, a real part and a square root part? Okay, well, the reals multiplied by the real, so that's 3 times negative 5, and then the square roots multiplied by the square roots. So what this really looks like out here is a 3 times a negative 5 square root of 6. That's what that's happening right there. So the 5 times the 3 is the negative 15, and then the square root of 6 is along for the ride. And now I'm going to do it here. So it's the 5 times the 7, so negative 35, and then there's an extra square root of 6. Now those are like terms, so we can add those together. So negative 15 and negative 35 is negative 50 square root of 6. The square root of 6 can't break down any further, so that one is done. Okay, number 12. The 2 and the 5 get multiplied together, and then the square root of 3 is along for the ride. Okay, out here, the 2 and the 2 get multiplied together to be a 4, and then the square roots are 3 times 7. So the real numbers multiply, and then the square root numbers multiply. Now 21 could be a 3 times 7, but neither one of those are perfect squares, so we don't go any further. That's actually it. 10 square roots of 3 minus 4 square roots of 21 doesn't go together any further. Okay, so that's how we multiply. The real numbers multiply and the square roots multiply, then you fix it. Okay, division, it's basically the same thing. The square root of 8 over the square root of 36 could be rewritten as just the square root of 8 over 36. And now that does simplify. 8/36 is 1 over 4. Okay, and then we can break it back up again. So then that, see, they can be in pieces or they can be together. Same thing here, they can be together or they can be in pieces. And now the square root of 1 is 1 and the square root of 4 is 2. So the square root of 8/36 is going to end up being 1/2 with that string of events. That's one thing that we can do. Or we can break the square root of 8 apart. So one of the things I know is these two pieces are going to go down to 1/2. So really this answer is 5 times 1/2. Okay, I just want to show you a few ways to do this though. The square root of 36 is 6. And then up here on the 8, that square root of 8 is really the square root of 4 times 2, and the 4 comes out. Okay, so on the top I have 5 times 2, and then a square root of 2 is left on the inside. And on the bottom we have this 6. Okay, why is this not... Whoa! Okay, 8 over 36 is not 1/4. Hold the show here. 8 over 36, 8 over 32 would be 1/4. Let's see, we can reduce that though. It would be 4 over 9. No, cutting this, good grief. Cutting this in half would be 4 over, what do we have? Yeah, 9. Still have the square root of 2 up there. Oh, man, what am I doing? Why can't I reduce 8 over 36? Okay, let's cut them both in half. Okay, it's 4 over 18. Okay, we can cut those in half again, and now it's 2 over 9, which would be the square root of 2 over the square root of 9, and now the square root of 9 is actually 3. Okay, so all of that ended up being the square root of 2 over 3. Now, that probably, hopefully that didn't get you all confused, just because I couldn't reduce 8 over 32. Okay, it's 4/18, which is 2/9, and now the square root of 9 can be a 3. It's the square root of 2 divided by 3. Okay, now notice what we were doing. I was taking just that piece. There's a big 5 in front of all that, so there will be a big 5 in front of all that, and that will end up being the answer. 5 square roots of 2 on the top over 3. Okay, now let's look at it this other way that we did it. I fixed the 8 and made it 4 square roots of 4 times 2 and brought out the 2. Okay, 2 times 5 is 10, square roots of 2, and the bottom is 6. Now how are these two things the same? Well, we can cut the 10 and the 6 in half. That becomes 5 and that becomes 3. So our final answer is 5 square roots of 2 on the top and a 3 on the bottom. Sometimes that's called 5/3 times the square root of 2. Those are the same idea. Okay, let's do another one and see. Try to not get too crazy here. How about we just, first of all, the square root of 64 is 8. So the bottom here is 40. Okay, the square root of 12, though, is 4 times 3. Break out the 4. So here we really have 4 times 2 square roots of 3. So 4 times 2 is 8 with that extra square root of 3. Okay, now we'd look at the real numbers, the integers, see if we can reduce that, and then we look at the square roots and see if we can reduce that. Well, we can reduce that. 8 goes into itself once and into 45 times, so that is the square root of 3 divided by 5. Okay, so both of these, one of the square roots in the bottom, the square root in the bottom actually went away, but that does not always happen, like here. Okay, there's really nothing left to do. We could turn that 7/35 into a fraction like this, 7/35, which is the square root of 1/5, and put that back. So that would be the square root of 1 on the top and the square root of 5 on the bottom. Okay, if we did that, so that we would replace this part with that. So we would have 7, and then square root of 1 is just 1 over the square root of 5. Okay, so that would end up being 7 divided by the square root of 5. But there's a rule that I haven't told you yet about division. When you have fractions, you're not supposed to have square roots in the denominator. Okay, so the way we get rid of square roots in the denominator is we multiply it by another one. So if I took a sidebar here and multiplied by the square root of 5, See, the square root of 5 times the square root of 5 is square root of 25, which is 5. Okay. If I do that, it makes the bottom 5. Well, you can't really just go multiplying by the square root of 5 unless you do it to the top also. Now look why that works. See, that's the square root of 5 divided by a square root of 5, which is just the number 1, and 1 times anything is the same value. So multiplying by a square root of 5 on the top and the bottom doesn't change the answer, it just changes the look. And that's what we want. We just want to change the look. So 7 times the square root of 5 is just 7 square roots of 5. That's considered the simplest form, to not have a square root in the bottom. I know it looks like it's more complicated than it was, but square roots are typically not allowed in the denominator of a fraction. So that process, I fixed the 7/35 first, and then threw in the 7, and then fixed the denominator. We could fix the denominator first. I'm giving you two options on how to do this. What if we just fix the bottom first? See, I multiplied by 1, so that won't change anything. So now on the bottom I have the square root of 35 times the square root of 35, which is 35. And on the top we have 7 times, now whatever 7 times 35 is, 245. Okay, well, let's see. The square root of 245, I'm going to use my calculator here just a little bit. So let's see if that can break up into one of those perfect squares. 245. I'd like to see if 9 will. So 9 is not going to cut it. 245. 9, 16 is not going to go in there. The next one would be 25. It's not going to go in there. 30. So what I'm going down the list in my head, I'm going to try 49. 245 divided by 49. Okay, sure enough, that's 5. So this 245 is really what was it? 49 times 5. And that 49 breaks out of there as a 7. Okay, so now on the top we have 7 times 7, which is 49. We have a square root of 5 left, and the bottom is a 35. Okay, if that was my number, I could reduce both of those by 7. If I divide both of those by 7, dividing that by 7 gives us 7. Divide that by 7 gives us 5. And what we have on the top now is 7 square roots of 5 over 5, which is the same thing we got going that way. So you have a couple options here when you fix the denominator. You can fix the denominator right off the bat, or you can wait for a while and fix the denominator at the end. But in both cases, we cannot have a square root in the bottom. Okay, let's try another one. Let's look at 17. See, there's a square root of 5 in the bottom. That's the only thing that's messing it up, not the 2. The 2 is fine. So I need to get rid of the square root of 5. So I'm going to multiply by another one. Okay, that makes the top 6 square roots of 5. It makes the bottom, we have that 2 there, but now square root of 5 times the square root of 5 is just a regular old 5, and see how that cleaned up the bottom? No square roots. So now we have 6 square roots of 5 over 10, and of course 6/10. We can cut this one in half for a 3, cut that in half as a 5. So our final answer is 3 square roots of 5 over 5. Okay, let's try 18. It's only the square root of 3 that's the problem. So I'm going to multiply by square root of 3 to get rid of it, and multiply by square root of 3 on the top to get rid of it. Okay, so the bottom is just 4 times 3, because square root of 3 times square root of 3 is just a 3. Okay, but the top now, you have to multiply the entire top times the square root of 3, so both of them. So the front end is square root of 5 times square root of 3, that's the square root of 15. And then this one is the square root of 3 times the square root of 3, which is just the number 3. It's the square root of 9, but then that comes back down to 3. And that's how you answer those. It's the square root of 15 minus 3 over 12. Now we should check the 15. 15 could be 3 times 5, but 3 times 5 are not perfect squares, so they couldn't come out of there anyway. So that one is finished. Okay, 19. The 19 is a problem. All we have to do is multiply it away. A square root of 19 there and a square root of 19 there. Okay, 19 times 19 is 19. Now on the top, that square root of 19 has to go to that one and to that one. Okay, so square root of 2 times square root of 19 is square root 2 times 19 is what, 38. And then the regular 3 is on the outside, and now 3 times 19 has to go on there, so 38, 48, 57. So it looks like it's the square root of 38 times 57. Okay, that 38, okay, I need to check it for some perfect squares here. So 38, of course, divided by 4 is not going to work. 38 divided by 9, no. And 38 divided by 16, no. So the 38 is good. It has no perfect squares in it. What about the 57? I'm going to try 9, and then, of course, 9 is not going to work. So the 57 also does not have a perfect square in it. So that's it. It's the square root of 38 minus 3 square roots of 57, all divided by 19. Now 19 does not divide the 57 because this is a real 19 and that's a radical 57. So those don't go together. It's only the integer parts that go together. Okay, and now 20, it's the 5 that we have to worry about. So the bottom, 5 times 5 is 5. The top, I got to take it times 2, so that's 2 square roots of 5, and then square root of 5 times square root of 5 is 5. Okay, sometimes people want to cancel those two 5s out. Think about this. If we have 3 plus 1 over 3. Okay, everybody okay that this is not anything to do with that problem, but 3 plus 1 over 3 is really 4/3. Is it the same thing, 3 plus 1 over 3, if I cancel out the 3's? See how that's not the same? You cannot cancel out a 3 unless you can do it everywhere. If we had 3 plus 6 over 3, if you can divide them all by 3, if I divide that by 3, it's 1, divide that by 3, it's 2, and divide that by 3, it's 1. Okay, now I have 1 plus 2 over 1, which is 3. Look what we would have had if we'd gone the original way. 3 plus 6 is 9 over 3, which is also 3. See, that works. If you can divide everybody by the same thing, you can reduce it. But if you can only divide part of it by the same thing, you cannot reduce it. So that 5 does not reduce with that 5 because it cannot reduce with that 2. So that's it. 2 square roots of 5 plus 5 over 5. Okay, give some of those a try.